Hello everyone. In this video we are going to learn arrays in C programming through example programs. In the previous class we learned the basic concepts of arrays. Now we are going to apply that concept through different programs. We will learn how to insert elements into an array, store elements in a two-dimensional array, initialize and display an array, find the sum of array elements, find the smallest element, search for an element, sort elements in ascending order, perform matrix addition. Here the objective is not simply to memorize programs. Our target is understand how the index, loop and array elements work together. Let us first see how to insert or store elements in a one-dimensional array. Suppose we want to store 5 values 10, 20, 30, 40, 50. We declare an array int a of 5. Here int is a data type, a is array name, 5 is the size of the array. This means that the array can store 5 integer values. Remember an important point. Array indexing always starts from 0. Therefore, the 5 locations are index starts from 0. The value is in the 0th index. The value is 10. The first index the value is 20. In second index the value is 30. In third index the value is 40. In fourth index the value is 50. Now we use a for loop. Here for loop I equal to 0, I less than 5, I plus plus. If this condition true, it prints printf enter the element, then we are getting the value scan of %d address of a of I. Initially I is 0, therefore a of I becomes a of 0. The first value entered 10 is stored in a of 0. Then I becomes 1, so the next value is stored in a of 1. This continues until I becomes 4. If I equal to 0, a of 0 equal to 10, I equal to 1, a of 1 equal to 20, I equal to 2, a of 2 equal to 30, I equal to 3, a of 3 equal to 40, I equal to 4, a of 4 equal to 50. After this our array contains 5 values. Students, whenever you see a of I, don't think of it as a one fixed location. I is a variable. So depending on the value of I equal to 0, a of I equal to a of 0. I equal to 1, a of I equal to a of 1. I equal to 2, a of I equal to a of 2. This is why we can use a single for loop to process all the elements. Here a array name I index a of I particular array element. Now let us move from one-dimensional array to two-dimensional arrays. A two-dimensional array can be visualized as a table or matrix. For example, it has columns and rows. If we declare int a of 2, 2, this means 2 rows and 2 columns. Here the total elements 2 into 2, 4. For a two-dimensional array, we normally use two loops. The outer loop handles the rows, the inner loop handles the columns. See the code for I equal to 0, I less than 2, I plus plus. This is the outer loop. In inner loop for j equal to 0, j less than 2, j plus plus. Here it is 2, we can print enter the element, then getting the value using scanf statement. Scan of %d at address of a, I and j. Here I equal to 0, we are working with first row, I equal to 0. In the first iteration, outer loop I equal to 0, inner loop starts a equal to 0, ask for the element and stores in array of 0, 0. Then in inner loop j is incremented, then j equal to 1. It again asks for the element, stores in a of 0, 1. Then j equal to 2, the inner loop condition becomes false, then it moves to the outer loop. The second iteration of outer loop I equal to 1, then again inner loop starts again. Here j equal to 0, ask for the element stored in a of 1, 0. Then j incremented, j equal to 1, ask for the element and stores in array of 1 and 1. then again j equal to 2, the inner loop false, then goes for outer loop. There also condition false, then moves. When I equal to 0, we are working with the first row. Then I becomes 1, we working with second row. In first row we receives 1 and 2, in second row we receives 3 and 4. Therefore the output matrix like 1, 2 in first row and 3, 4 in second row. Always remember, outer loop is for row, inner loop is for column. This is one of the most important points should remember. Why do we actually needed arrays? Suppose I want to store the marks of 50 students. Without an array, I would have to create mark 1, mark 2, mark 3 up to mark 50. This becomes difficult to manage. Instead, we can write into marks array of 50. Now all 50 values are stored using one array name and different indexes. For example, if we want to store voltage readings from 5 measurements, voltage 10, 12, 11, 13, 15, we can store them as int voltage array of 5. This is one practical way arrays can be used in engineering applications. In this section, we are going to learn 5 important array operations: sum of array elements, then smallest value, biggest value, searching for a value, storing elements. While learning these programs, concentrate on the logic, not just the syntax. In this slide, we have array initialization and display. Here we declare int n of 10. Here int is a data type, n is the array name. In the square bracket we have 10. This tells the size of the array. Here n is an array of 10 integers. And then initialize the values using n of I equal to I plus 100. Here we are declaring n of 10, therefore we have 10 locations, n of 0 to n of 9. Now we look at for loop for I equal to 0, I less than 10, I plus plus. Here n of I equal to I plus 100. We are generating the values based on the index. I equal to 0, n of 0 equal to 0 plus 100 equal to 100. I equal to 1, n of 1 equal to 1 plus 100 equal to 101. I equal to 2, n of 2 equal to 2 plus 100 102. Likewise up to I equal to 9, n of 9 equal to 9 plus 100 109. So the array becomes 100, 101, 102, 103, 104, 105, 106, 107, 108 and 109. Then again we have a for loop. Why are we have two loops? This is an why are the two loops? The first loop as writing values and the second loop as reading or displaying them. Initially we assign the values. Now we are going to using second for loop display the values. The second loop read and displays those values. Here using printf percentage %t format specifier comma n of j. So remember, first loop is used for writing and second loop is used for reading. The values inside the array do not automatically change just because we use another loop. Another important point is the difference between the variables I, j and the array. I and j are simply loop control variables. They tell the program which position we are currently processing. The actual data is stored inside the array. Example, I equal to 2, n of I equal to n of 2 equal to 1 of 2. Here I stores 2. It does not store 1 or 2. The value 1 or 2 is stored in n of 2. Here we have the explanation of coding. First loop I writing the values, then in second loop j reading the values. I phase write values into each index of n of array. J phase writes from those exact same indexes. The array content does not change between loops unless you explicitly assign new values. I and j are just counters. They don't store the array's data. The array enough. Here we have the program sum of elements in the array. Initially hash include stdio.h. It includes the standard input output library function. Then we are using the global declaration hash define max size 100 throughout the program. Whenever we called max size, it replaces the value 100. Then main program starts. Here we initializing the array. Int is a data type, ar is array name. Then in square brackets we declared max size. Max size here always 100. Then initializing the variables I n sum equal to 0. I is a looping variable, n is the size of the array. Then we initialize sum equal to 0. After that we are getting the input size of the array. Here we using printf as a display message, enter size of the array. Then using scanf we getting the n value. After that we have a for loop. Here we use I equal to 0, I less than n, I plus plus. Then using scanf we treat the values of array of 0 to array of 4, because we have n value as 5. After getting the values, we using another for loop for adding each array element, to the sum. Here again on for loop is used for I equal to 0, I less than 1, I less than n, I plus plus. Sum equal to sum plus array of 5. This loop executes until n equal to 4. From array of 0 to array of 4, the value is added and stored in this sum. After that we print the sum value. Now suppose the user enters 2, 4, 6, 8, 10. We want to calculate 2 plus 4 plus 6 plus 8 plus 10 equal to 30. Here we need a variable called sum. Initially in sum equal to 0. This is very important. We initialize sum to 0 because we are going to add values to it one by one. In first for loop, this loop reads each value from the user and stores it into the array. For input 2, 4, 6, 8, 10, the array becomes index 0, the value has 2, index 1, the value has 4, index 2, the value has 6, index 3, the value has 8, then index 4, the value has 10. And again we have another for loop for some calculation. Here the iteration how to add the elements are given. After the loop finishes, the sum is 30. So the final output is sum of all elements of array is 30. The variable sum is called an accumulator because it keeps accumulating the total value. Now we are going to see the program searching the smallest value. Here always we have first line hash include stdio.h. It includes the standard input output library function. Then main function starts. After that we declare the array. Here int is a data type, a is the array name. In square brackets we have 30. So array A stores the 30 integer values. Then we declare the variables I, num and smallest. Initially we using scanf, we get the num value, that is the number of elements used in this array. After that we read the array values using the for loop. Now we want to find the smallest value in an array. Suppose inputs we have 2, 7, minus 3, 10 and 4. Here the number of elements in array is 5. From this we need to calculate the smallest element. In this input 2, 7, minus 3, 10, 4. What is the smallest value? It is minus 3. We know this, but how can the C program find it? So we first assume that the first element is the smallest element. Then smallest equal to A of 0. Therefore smallest equal to 2. Now we compare every element with the smallest. Array values we have 2, 7, minus 3, 10, 4. Initially smallest equal to 2. Then compare 7 less than 2. The condition is false, no. So smallest, no changes here, smallest equal to 2. Then compare minus 3. minus 3 less than 2, yes, therefore smallest changes to minus 3. Then again compare with 10. 10 less than minus 3 is no, so there is no change. Then compare with 4. 4 less than minus 3 is no, so there is no change. Finally the smallest value is minus 3. For this comparison, here we use a for loop, then if loop. If we are checking the smallest number, if it is a smallest number, we update the AFI value. If not, again we comparing with the other numbers. After final execution, we print the smallest value. Here the smallest element is minus 3. Now we are going to see the program searching the location for the given value in an array. See the program, first line always hash include stdio.h. Preprocessor includes the standard input output library functions for the functions like printf and scanf. Then main function stats. Here we declare the array int data type is array name. In the square bracket we have 30. 30 is the size of the array. Here array A stores the 30 integer values. Then we have the variables num element I equal to 0 initially. Then we are getting the input using scanf, how many numbers used in this array. After this we have a for loop for reading the array values. After that we need to search a element existing in this array or not. For that we are using the while loop here. Suppose our array is 10, 25, 30, 40, 50. Here the number of array elements is 5. We have inputs 10, 25, 30, 45, 50. Now we are going to search the element. Searching element is 30. We need to check whether 30 exists in the array or not. The method used here is called linear search. Linear means we check the elements one after another from the beginning. First 10, then 25, then 30, then 45, then 50. We don't jump randomly. We start at index 0 and compare each element with the search value. In while loop, we have the condition I less than num. Using AND operator, element not equal to A of I. Then we increment the I values. There are two conditions. In condition 1, I less than n. This ensures that we don't go beyond the array. In condition 2, element not equal to A of I. This checks whether the current array element is different from the value we are searching for. We using AND operator. The AND operator means both the conditions must be true. We have array A. Index starts from 0 to 4. The values are 10, 25, 30, 45, 50. And the position is always different from the index. The position equal to index plus 1. Initially I equal to 0. Then we check the while loop condition. I equal to 0. Then 10 not equal to 30, I becomes 1. It is true, then I value updated, I equal to 1. The value is 25. 25 not equal to 30, I becomes 2. Then I equal to 2. The value is 30. 30 not equal to 30. The condition checks. The condition false. The loop stops because we found the element. Then see the program. After finding the element, we print the position. The position equal to I plus 1 because array indexing starts from 0, but the human normally count the position starting from 1. So index 2 equal to position 3. Now suppose we search for 15. The program checks 10, it is not equal, then 25 not equal, then 30. This is also not equal, then 45, then 50. These all are not equal. After checking the last element, I equal to 5, num equal to 5. Therefore I less than num becomes false. So the program concludes element not found. When using arrays, always make sure that your loop condition prevents accessing an invalid index. The explanation is given here. Now we see the program sorting the elements in an array in ascending order. C program always starts with hash include stdio.h. Preprocessor directory includes the standard input output library functions for printf and scanf functions. Then main program starts here declaring the array in the of 50. Int is the data type, A is the array name. Inside the square brackets we have 50, so array A stores the 50 integer values. Then we have the input variables n, I, j and temp. Initially using scanf we read the number of elements. Then we use a for loop for reading the input values. After that we using two for loops and if statements for sorting array in ascending order. After that using the for loop we display the sorted array. Now let us learn starting. Suppose the input is 23, 5, 12, 7, 3. We want to sort as 3, 5, 7, 12, 23. Sorting means arranging the elements in a particular order. Here we are using ascending order. Sorting requires comparing one element with other elements. Therefore, we use two loops. For I equal to 0, I less than n minus 1, I plus plus. As outer loop, then inner loop for j equal to j plus 1, j less than 1, j plus plus. After that we having the if condition checking a of I greater than a of j. After that we have some conditions for changing the values. I selects the current position, j checks the elements, after that the position. The if condition asks if a of I greater than a of j. If the left value is greater than the right value, we need to exchange them. Then we have swapping of two values. This is an extremely important concept. Suppose a of I equal to 23, a of j equal to 5. We want a of I equal to 5 and a of j equal to 23. We cannot directly do a of I equal to a of j equal to a of 5, because after the first statement the original 23 is last. So the correct method is temp equal to a of I, then a of j value stored in the a of I, after the temp value stored to a of j. Here initially temp equal to 23, then the value of 5 is stored to a of I, then 23 is assigned to a of j. Now the values are successfully exchanged. See this table, complete execution is and iterations are given here. Initially the input is 23, 5, 12, 7. In first comparison, 23 greater than 5. Yes, sir. We swapping 5, 23, 12, 7, 3. Next 5, 23, 12, 7, 3 compared with the, then we compared with the 12. 5 is smaller, so there is no exchange. Continue the same process until all values are arranged. Finally, the values 3, 5, 7, 12, 23. In this slide, we have all the iterations and process clearly explained. Don't try to memorize every comparison. Understand this basic idea. Compare, decide, swap if necessary. Finally, the output is final sorted array is in ascending order is 3, 5, 7, 12, 23. Outer loop I selects the element, inner loop j compares it with the remaining elements. If the current element is greater, we swap to place the smaller element before it. In each pass, the element a of I is compared with all the elements after it. If a of I greater than a of j, we swap them. After all the passes, the array is sorted in ascending order. The final output is 3, 5, 7, 12, 23. Now I explain our final program matrix addition. Always first line has include stdio.h. Preprocessor directory includes the standard input output library function. Then we have the main function. After that we here declaring the three array variables, two-dimensional arrays, int, array of A, array of B and sum. We declare the variables R, C, I, J. After that we getting the row and column size using scanf. After that, we get the input first matrix using two loop variables ing, row size and column size. We get first matrix. After that, get second matrix using two for loops. After that, we add this two matrices. The added result is stored in the sum of ing. After that, using two for loops, we display that sum matrix. The important rule is sum of ij equal to a of ij plus b of ij. That means first element plus first element, second element plus second element. Likewise, it goes. For example, a of 0 0 plus b of 0 0, that is 1 plus 7 equal to 8. Similarly, a of 0 1 plus b of 0 1, 2 plus 8 10. Likewise, it goes. Therefore, the result is a 8 10 12 14 16 18. Here we are using nested loops in matrix addition. For matrix operations, remember our previous concept: outer loop for rows and inner loop for columns. Here we have two matrix A and matrix B. After that, we have the sum of the two matrices results. Program, we get the two input matrix. After that, we adding that two input matrix and store this result in sum. After that, the sum matrix is displayed. We have first matrix 1 2 3 4 5 6 and second matrix 7 8 9 10 11 12. This both matrices are added using the formula sum of ij equal to a of ij plus b of ij. Element by element addition is done, then finally displays the result. Final sum matrix equal to 8 10 12 14 16 18. Let us quickly revise what we learned in this lecture. First, an array allows us to store multiple values of the same data type using a single array name. For one-dimensional array of index is used to access an element. Remember that indexing starts from 0. For a two-dimensional array of row column is used. We use nested loops when processing rows and columns. Some important operation we need to remember: insertion. Idea is store values using index. For display, read values using index. Sum. Accumulate all values, smallest, compare and update minimum, searching, compare one by one, sorting, compare and swap, matrix addition, add corresponding elements. References. Thank you. Happy coding.